So what we're starting today is functions. And what we're going to really cover a lot of today is determining whether something is a function or not. Now, a relation pair of inputs and outputs, a relation pair of inputs and outputs. When a relation is given as an ordered pair, the x-coordinates are inputs and the y-coordinates are outputs. So x is what we put into the function, y is what we get out of the function. X is what we put into the function, y is what we get out of the function. Now, a relationship that pairs each input with exactly one output is a function. So each input has exactly one output, would be considered a function. So if we look at this here, we want to determine whether these ordered pairs are a function. So if it's a function, we have exactly, for each input, we have exactly one output. So -2 goes to what output? 2, yes, because input is x, output is y. We're taking -2 to 2. And where does -1 go? The next one, it goes to 2 also, yes? 0 goes to 2. 1 goes to, not 2, it goes to where? 0. Yep, and 2 goes to 0. Would this be considered a function? Yes, because each input has exactly one output, yes? Now, the outputs for some of these might be the same, but that's fine. That's perfectly fine. What we cannot have is having one input to two outputs. We cannot have the same x value going to two different values. Yes, because each input has how many, has exactly one output. It doesn't matter that we have repeated outputs. Each input has exactly one of them, one output. Each input has exactly one output. So I was going to ask that on the homework. It's going to ask you to explain why it is or is not a function. Well, this one is because each input has exactly one output. And that's it. Questions on this here? Determine whether each relation is a function. So let's look at this one here. So the inputs I have, I'm going to go on and list them out. We have -3, -2, -1, 0, and 1, yes? Because those are the x's. Those are the input values, yes? So let's look at the output values. Well, -3 goes to 1. -2 goes to 1. -1 goes to 0 goes to 1, and 1 goes to 1. Is this a function? Yes. Because each input has what? Exactly one output. Each input has exactly one output. And that's it. So sometimes with these ordered pairs, it might be easier to write it this way. I think it's easier to write it out, kind of showing where the x values go. Questions on this here? Let's look at the next one. Here we have 4, 5, 6, and 8. Yes, those are our inputs. Well, 4 goes to, 8 goes to, 6 goes to, 4 goes to 3, and 5 goes to 2. Is this a function? No. Because Because one input has two outputs. There's at least one or more input, because our input has at least two outputs.
So, if the 4 had, if there was another number in place of the 4, would it be 18?
Right, so if this had been 5 or 1, 0, then it would work, because since we have 4 and 4, two inputs going to two different, we have the same input going to two different outputs, it does not work. It does not work, and that's the reason why it doesn't work. Because the inputs, we cannot have two inputs, a input value going to two different outputs. Since 4 goes to both 0 and 3, this is not considered a function. It is not a function. Right. So the relationship is not a function because we have two outputs, one input going to two different outputs. Questions on this here? We good with this here? Let's look at this one here. So I have 1, I have a 2, I have a 3, I have another 1, and then I have a, well, 1 goes to 3, 2 goes to, 3 goes to, 1 goes to, and 4 goes to. Because an input has two outputs. Because I cannot have an input value and x value going to two different y values. It just doesn't work. When an input value has two different output values, when an x value has two different y values connected to it, it is not a function. It is not a function. Questions on this here? Determine whether each relation is a function. Now we can do the same thing, or we can look at the x values. -2 goes to 3, -1 goes to 4, 0 goes to, 0 goes, oh wait. I have two 0 values, don't I? So can this be a function? Because I have 0 going to two different values, yes? So no, because an input has two outputs. So it's not a function. So for it to be a function, we cannot have two output values for the same input. Any questions on this here? Looking at this one here, can we say this is a function? Saying yes, yes. Why? Each input has exactly one output. Each input has exactly one output. Questions on this here? How about this one? Is this a function? Well, yes, because each input has exactly one output. So I have a feeling y'all are getting the hang of this, yes? How about this one here? What do we say, yes or no? No, because 2 goes to what? -4 and, so it doesn't work. We cannot have 2 outputs for one input. One input value cannot go to 2 outputs. So we have these here, and I feel like we can say, do we feel comfortable with these? Yes? So looking at these here, one would be no. Number 1 would be no, because we have 5 going to 0 and 5 going to 10. That doesn't work. Number 2, -4, -1, 2, 5. This one actually does. This one works. This one does. That one does not. Because the last one we have 1 input and 3 outputs. So it will ask you on the homework assignment to give a reason. So this one here, yes, because each input value has exactly 1 output. This one here, number 4, well, no, because each input, or the input value, has 3 outputs. It's actually going to have drop-down menus, and you have to fill in. Okay? So do we feel comfortable with these here? Now, another thing that we did with determining if it's a function is something called the vertical line test. Vertical line, straight up and down. If I can draw a vertical line on the function, or on the graph of the function, and it crosses more than once, it is not a function. If it crosses more than once, it's not a function. Make a vertical line. So looking at this here, do any of these points cross more than once? No, they only hit that one point, yes? Let's look at this one here. Yeah, there's several places where this crosses more than once, yes? So this, yep, so this one's not a function, this one is. So, another vertical line. So B would be yes, because there's nowhere I can draw a vertical line and it crosses more than once, correct? Now A, there it crosses twice, doesn't it? We have 2 points. Here we're fine. Well, hey, it failed again, yes? So as a function? No. Because it failed the vertical line test. No, it failed the vertical line test. Yes? Because it crossed more than one spot. I mean, most of this is going to be fill in for the homework. You're not going to have to type anything. Because I don't think you've had to type a sentence yet, have you? No, it's not that bad. This one here would be yes, because why? It passed the vertical line test, yes. Yes, it passed the vertical line test, so it is a function. Any questions on either one of these two? How about this one here? Yeah, we can draw a straight line. I mean, we can mentally draw a straight line going up and down and see that, yes, this passes the vertical line test. There's no 2 points that this would cross. Yep, all of these cross at only 1 point, so we can say yes, because it passes the vertical line test. Questions on this here? What do we think with this one here? Yes, no, yes, no. Because if I draw a straight line, well, no, because it crosses more than once, yes? So this is not a function. No, because it fails the vertical line test. That fails the vertical line test, so it doesn't work. So what would we say with number 5? How about number 6? It's actually yes. So let's actually, right? Now if I look at this here, as I drag this across, it's only crossing at one point, yes? Now if we looked at the full graph, it might look like this one here might look like it wouldn't. Because as you start seeing here, it's getting real close, isn't it, to where it could cross twice? But it actually only crosses once. It would increase to where it looks like it's a straight line at a certain point, but it's still only going to cross once. This is a function. Both of these are functions. How about our circle? No. How about this one here? This one would be yes. And there is such a thing as the horizontal line test. There is such a thing as a horizontal line test. The horizontal line test tests for inversibility if you can take the inverse of the function. But it's not something you will, I don't think we'll cover it. We might, but most likely it'll be more Algebra 2. We won't really cover the inverse or how to, actually we will a little bit. But that's the horizontal line test for inversibility. Can we take the inverse of the function? Domain and range. I have a feeling you've heard of these two, yes? Domain is what goes into the function. The range is what comes out. Domain goes in, range comes out. And normally when we talk about domain, we're talking about the x values, the input values. Range is the output, the y values. So what we're going to be doing next is we are going to be talking about what is the domain and what is the range and naming it. Now we look at this here. What are the x values? Our domain. Well, we look coming across here, well, I have a value at, this would be -3, yes? And then I have a value at -1, 1, and 3. Those where the points are at for the x's, yes? So the domain would be -3, -1, 1, and 3. It would just be the x values of these points. Because we just have a point, it would just be that location. It's not going to be everything because it's just a set of points. Any questions on letter A so far with domain? So what are their y values? So what y values do we have? Well, one of them is -2, isn't it? What's another one we have? So what would this one be? That's right here. 0, because at the x-axis, the y value is 0. It's always going to be 0 at the x-axis. But we have two more. We have one here and one here. So what are those other two values? Well, this one would be 4, because we have 4 all the way up at the top. Yes? Actually, I think that's it, because there wouldn't be one for 7, because we would need 7 up there. Does that make sense? Or because 7 would be somewhere up here. It's not included on the graph. But that's it. That's our domain and range when we're given points. Because points are just those individual numbers, the x and y coordinates. Questions on this here? Now, I'm going to erase that so I have a little more space. Are there points, just points on this graph here? Well, we have a start and end point, but we don't have individual points. We have a line, don't we? So when we talk about a line, the domain is going to be written in interval notation or in our inequalities. We're going to write it as an inequality. What is the smallest value of x? Going from left to right. It's right here, isn't it? What is the value of that x? And it goes this direction. And what's the biggest one? Positive 3, yes? So what we're saying is what? Negative 2 is the smallest value and 3 is the biggest, yes? So we have this here. Now, is negative 2 and 3 included? Are those values included as x? Are the dots there whole or open? Both of these are closed. I said the same thing, I know, I just realized. But both of these are closed, aren't they? So what we would say is that these are equal to. So negative 2 is less than or equal to x is less than or equal to 3. And that's our domain. Any questions on the domain, how we did this one here? Now let's look at the range. So the range, we're looking at the up and down the y. What is the smallest y value that this function crosses? Negative 1, and what's the biggest? 2. Can we? It's pretty much we're just scrunching it in onto that axis. We're seeing what is covered. Well, it only goes down to negative 1 because that's the smallest value, yes? Because y is going to be bigger than it, and it's also going to be smaller than 2. And we're going to include both of those values. Questions on this here? We good with this here so far? Yes? Nothing's too bad yet? Awesome. I wanted to see how they wrote those. We're going to do another one here. Now, do we have a line? Or do we have points? Points, yes? So since we have points, we won't use an inequality. Because we only use inequalities if we actually have a graph of a line. So we have 2, 3, 4 points, yes? So how many domain values should we have? 4, because we should have one for each of those points, yes? How many range values should we have? 4, one for each of those points. The only time we would have less range values or less domain is if one is repeated. So the domain, what are the x values for these points? So this would be negative 3, yes? How about the next one? It would be at negative 1, and then 1 and 3, yes? Negative 3, negative 1, 1 and 3. Those are our 3 domain values. Negative 3, negative 1, 1 and 3, because we're looking at the x. We want to see where are they located on the x-axis. Now, so it'd be all 4 of these. Now the range, we're looking at the y values. It doesn't matter where we start. We can start down here. So this point has a y value of what? What is its y value? Negative 3, so that's the first one. How about this next point? Negative 1. How about the y value for this third point? And the last one would be 3. So it worked out that the domain and range were the same, but they don't quite line up the same because each point kind of is flipped. But the domain and range, the domain is -3, -1, 1, 3. The range is -3, -1, 1, 3. And that's it. That's all we have to do for this here. Questions on these here? Are you ready for the next one? So, this here, right. I'm going to separate these a little bit because I'll need space. Now, this here is a graph. We have a line, don't we? Or a curve. We have more than one point. We don't have just dots. So the domain and range are going to be written as an inequality. And it's always going to be this compound inequality. Domain is going to have x in the middle, range is going to have y in the middle. So looking at this here, the domain of this function. So if I look at the x's, go in this direction here. What is the smallest x value that this function has? Almost it would be -1 because it's past the y-axis, it's in the negatives, so it'd be -1. What is the biggest value? So it'd be +3 because it would be 3, yes. So the domain would be between -1 and 3 for the x-axis because we're seeing kind of where does it fall on the x-axis. Now the y, we're going in this direction here. So what's the smallest value for y? So going down, -3 is actually the smallest value. Because if we look down here, this is the smallest point on the y-axis, yes? So the smallest y value would be -3. The biggest is at 2. And that's the range of this function here. Questions on this here? Now, most functions, because here we have a stop and end point. We have 2 endpoints, yes? It doesn't go on any further. For this function here, in most functions, if we talked about them as a whole, their entire function, the domain is normally all real numbers because we can plug any value in. But since they kind of restricted us that it started and stopped at these points, it restricted the domain and range. Any questions on this here? Yeah. Let's look at the domain for this one. What would the domain be? So look at the x values for these points. Well, this one here. So what are the x values for each one of these points? Well, we have -2, 0, 1, and 2. Now, because they're individual points, we have to name each one of them because they're points. So we would name each one of those points. Now, how about the range? So we're looking at the y values. So we wouldn't look at them this way. We'd look more, well, that one's right there, going this way. So what's the range value for this first one? How about the next one? And then what's next? Do we have it listed? Yeah, how about the next one? we do not repeat any of the range. If the range repeats or if the domain repeated, we would not repeat those values. Because when I write domain, I would actually write it 0 to 4. I would normally write it from smallest to biggest, but this is fine. That would be it. That would be the range. So even though we had some values that repeated themselves, we just left them out. They're already included. Questions on this here? Now this one here, domain, range. Now the domain, so again, we're going to have an inequality. The range, we're going to have this inequality. So looking at the x values, what is the smallest x value, the farthest one to the left, that this function has? One, and the biggest is? Because again, we're mainly looking at this here. Where does the function cross the x's? Or where do we have a value for x? Now the range is going to be going this way, up and down. So with 4, so 4, I would agree 4 is one of the values. Is it the biggest value or the smallest? Because the function doesn't go above y equals 4, or where y is 4. What's the smallest value we have? So 0 is less than or equal to y is less than or equal to 4. And for the range, and the domain is 1 is less than or equal to x is less than or equal to 5. And that's all we have for this here. Questions on this here? So I know we have a few more slides, don't we? Or sheets. This here, I believe, is the last thing we're going to cover, independent and dependent. Independent, an independent variable. The variable that represents the input of the function is the independent variable because it can be any value in the domain. The x values, the values we plug into the function, are independent. We can change that value. The dependent variable is called dependent because it depends on the value of the input. Because what we put into the function will change what comes out. When we change the x, when we put something in for x, it changes the value of y, input and output. So for us here in most linear function, in most functions, we call the dependent variable y, and we call the independent variable x. So looking at this here, this function, y equals negative 3x plus 12 represents the amount of y in fluid ounces of juice remaining in the bottle after you take x gulps. So what's the independent? The independent is x or r gulps, and the dependent is y, our juice, our fluid ounces, because that's what would be left over. Any questions on this here? Yes. So our independent is going to be the x. And they're going to give us some information kind of describing it here. It's talking about the number of gulps. And y is the fluid ounces of juice, or how much juice is remaining. Now we have this here, the domain, 0, 1, 2, 3, 4. Yes? And what that's saying is we're going to take 0 and plug it in for x. Plug it in for our function. So our function is negative 3x plus 12. So what we're going to do here is we're going to plug each one of these values in. So the first one we can plug in is 0. Now at this point here, if we want to type this in the calculator, into a calculator, we can. Or we can do this by hand. So negative 3 times 0 is 0. Anything times 0 is 0. And 0 plus 12 is 12. 0 plus 12 is 12. So one of our range values is what? 12. So one of the range values is 12. Now what do? We go to the next one. We plug in 1. So we'd have negative 3 times 1 plus 12. At this point here, we can do negative 3 times 1, which is negative 3, because 1 times negative 3 would be negative 3. And negative 3 plus 12 would be 9. Questions on this here? Well, then we would do it with what? 2. Well, negative 3 times 2 would be negative 6. Well, negative 6 plus 12 would be 6, yes? Then we're going to do it with negative 3. Well, negative 3 times 3 is negative 9. And negative 9 plus 12 would give us 3, yes? Any questions on any of this so far? And lastly, we want to check this with 4, because negative 3 times 4 is negative 12, and negative 12 plus 12 is 0, yes? Would we keep going beyond 4, the x value of 4? Well, no, because what is the output, our dependent variable? It's the amount of juice that is left. Well, after 4 gulps, do we have anything left? No. So the overall range is 12, 9, 6, 3, and 0. And that's it. Questions on this here? Done with that one? Sweet. Any questions on this here? Now the rest of the questions are the same thing. They're the exact same thing. I want you to give those a try. If you get stuck, let me know. Okay?